In today's class, we'll be discussing about operators in Python. Operators in Python. One of the most important topic since it is a basic topic, but it is having a lot of importance. See, before going to see different types of operators, we need to understand what is an operator, right? So, what is an operator? Operator is a symbol, right? So, operator is a symbol which will perform operations, right? So operations on operands, operations on operands. These operands are called as values in the variables, values in the variables. Let's suppose you have a variable x, you have a value stored inside this variable 10, right? Let's suppose you have another variable y whose value is 20. All right, so I want to add these two values where those values are present on these variables. Is it right? Inside these variables, these values are present. So if I want to perform any operation on the values, you will use operator. Right? So operator is a symbol which will perform operation on operands. So you can think of like x plus, all right? So x plus y. So these are operands. Is it right? X and y. So directly I'm representing x and y here. So indirectly you are storing the values inside these containers. Is it right? So on these values you are applying some operation, right? So this symbol is an operation. So this symbol is called as an operator. So operator performs some operation on operands. All right. So how many different types of operators are available in Python? So there are different types of operators, like we have arithmetic operators. All right. So arithmetic operators. We have relational operators. Right, relational, you can also call them as a comparison operators. Relational operators or comparison operators. You have equality operators, right? You have logical operators, different types of operators, right? We have assignment operators, right? We have ternary operator, ternary operator, all right? So ternary operator, generally it is a conditional operator, all right? So if else, if conditional statements in one single line you can write. So that type of writing, that type of representation is called as a ternary operator. Like this, we also have identity operators, we have membership operators, right? So membership operators. So identity and membership operators both comes as special operators in Python. If anybody asks you what are special operators, you need to make them understand. So identity and membership operators are special operators in Python. At last, we will discuss bitwise operators. All right. So these are multiple types of operators. Arithmetic, relational is also called as comparison, because whenever you are deriving relation, you will compare two things. Is it right? If I am black, if you are white, right? I can say Madan is black. How you can say Madan is black? If you compare Madan colors with other person's color. Is it right? So you are just comparing, right? So relational operators are also called as comparison operators. Like if you want to check the content, right, is the content equal or not, you'll go for equality operators, right? So based on some logical expression you want to derive some result, so you'll go for logical operators. If you want to assign some value, right, to a variable, you'll go for assignment operators. Like ternary operators, you have to check the address, you'll have identity operators. To check the presence of an element, right? So in a sequence, it can be list, tuple, right? String, range data type. So you'll go for membership operators, right? If you want to perform mathematical operations very quickly, right? You will go for bitwise operations. One simple example that is, right? You can implement that in digital circuits, error detection circuits, right? But in automation, we will not use this frequently, but we'll learn this. All right. So if you see, what are the different types of arithmetic operators? We have addition. All right. So we have subtraction. So these are very basic operations from the childhood onwards we have been learning, right? So multiplication, division, like floor division, modulo division, all right, exponent operator, and it is also called as a power operator. So exponent is nothing but raising the power a square, 2 is for the power, square is for the power. So a cube, cube is for the power, 3 is for the power. So exponent operator is also called as power operator. All right. So these are multiple types of arithmetic operators. But there is a difference between division operator, division arithmetic operator, floor division arithmetic operator, modulo division arithmetic operator. First, let us see an example. With that example, we'll derive the difference between these three divisions, right? Both are divisions. But even though they perform divisions, there is some difference between these operators: division, floor division, as well as modulo division. Right. So creating day 3. Right. So inside day 3, creating a Python file, operators. Python file is also called as module. So module is nothing but .py file. So operators .py. So operators module it is called as, right? So first type of operators is arithmetic operators, right? So arithmetic operators, any type of operators, they will perform some operation on the values. Is it that is general thing, that is fixed, right? So let me define two variables, a and b. So a is storing some data or the value which is 10, b is storing some data which is 2. So a equal to 2 and b equal to 2. So on these values I want to perform this arithmetic operations. All right, for that I will use arithmetic operators one by one. Right, first is a plus b, right? Print of, so a plus b. And one more important thing, every operator or every operation will return some result, right? Every operation, it can be arithmetic, relational, ternary, identity, bitwise, any operator upon performing some operation will return some result, right? What you can do, you can store that result inside another variable. You can use that variable in subsequent operations. But if you want to see the result, right, if anything is returning, if you want to see that, you can use this print statement, right? If anybody is giving you the gift in the function, right, what you will do, you will open that. So using this print here, nothing but opening a gift. So this operation is returning me some result. So to see what result it is giving, I'm using this print statement, right? Print of a plus b, right? Print of a plus b. So 10 plus 2, it is a 12. Like this, we'll also see few more operations, right? Print of a minus b, right? Print of a into b, right? So a into b. Similarly, print of a division of b. We have floor division a, floor division of b, a modulo division of b. So modulo division symbol is percentile, right? Floor division is double forward slash. This is forward slash. If I specify like this is a backward slash. So one of the escape character, right? So if you specify single forward slash, it is a division operation. All right. So let us see exponent also, nothing but power operator. So if you specify double star, it is a power operator. So double star is what? A power operator, exponent operator, right? So if you perform addition, 10 plus 2, it is 12. 10 minus 2, it is 8. 10 into 2, it is a 20. So into means a star operator, multiplication star operator, right? Division 10 by 2, right? So 10 divided by 2, it will return you some result. So let you understand that result. So 10 floor division of 2, right? So 10 modulo division of 2, right? So 10 square, right? So 10 to the power b, a to the power b. So a is 10, so b is 2. So 10 square it is, right? When we execute this run operators, you can see 10 plus 2, it is 12, 8, all right? So 25.0. Observe these results. It is 5.0, 5.0. So like this, floor division is having 5. right? So modular division is having some result of 0. Good. So a square b, nothing but a to the power b, right? So 10 square it is 100, right? So if you observe these guys, these three operations especially, these three are divisions. But what is the difference here? If you perform normal division, it is returning you some float result. But if you perform floor division, it is also returning you, but that result is an integer result. But if you perform modulo division, it is returning you 0. Why it is returning you 0? So internally it is performing some division. So upon performing some division, it is returning the remainder, not the quotient. So these are all quotient. Is it right? So we'll get quotient and remainder. When we perform any division, you'll get a quotient and remainder. So if it is a normal division, if it is a floor division, they will always return the quotient. If it is modulo division, they will return a remainder. Right? Let me write that point. Very important point. Most of you people will confuse here. So when we talk about arithmetic operators, especially division. So when it is division, so division will return quotient. Will return quotient. Similarly, floor division also. Floor division also will return you the quotient. Floor division, right? So floor division also returns you the quotient. So double forward slash is what a floor division. So it will also return you the quotient. All right, good. So coming to this modulo division, right? So modulo division, very important difference. It will always returns you the remainder. It will always returns you the remainder. Good. But if you observe, whether it is normal division, whether it is floor division, they are returning you the quotient. Good. But if you see, the quotient is a float value if it is normal division, and the quotient is an integer if it is a floor division. Why? Right? You observe one more thing. I'm just commenting these other operations. Right? So I'm also commenting this modular division operation. I'm specifying 10.0 for A. Right? So, and for B, it is 2. All right, let us execute this. Let us observe. So you can see it is returning 5.0 again. Good. So in the another operation, it is returning me 5.0. And the same floor division operator, instead of integer, right, it is returning me float value. Is it right? Why? In what case it is returning? If at least one argument, one value is float value, this floor division operator is returning me the float value. Observe here, if at least one argument is float value, this floor division operators is returning me a float value. Otherwise, if both the arguments are integers, then it is returning me an integer value, right? So if you observe this normal division, even though it is float, if at least one argument is float, if both the arguments are integers, it is always returning me the float value. It is always returning me the float result. So both division and floor division operators, they will return you the quotient, provided, right, provided if both arguments are integers, or at least one argument is float. Anything is fine. So if both the arguments are integers, or at least one argument is float, it will always return to the quotient as a result. So that quotient is a float value, right? That quotient is a float value. Coming to this floor division, it will also return you the quotient. But which quotient it will return? It will return float, or it will return integer quotient, right? If at least one argument is a float, it will return you the float result. If both the arguments are integer, so it will return you the integer result. So these are very, very important. Division and floor division returns you the quotient, right? So if both the arguments are integers or at least one argument is a float or both the arguments are also float, always this division operator will return you the float value. But coming to this floor division, it will perform floating point arithmetic and it will perform integer arithmetic. When it will perform floating point arithmetic, if at least one argument is a float, the result is a float. Is it right? If at least one argument is a float, the result is float here. If both the arguments are integer, then the result is integer. So it will perform floating point arithmetic and integer arithmetic. Right? The same arithmetic operators, the same plus operator, the same star operator, you can also apply on strings, not only on integers. Plus and star. So addition and multiplication, there you will call as concatenation and repetition operators. These two operators not only on integers, you can also apply on strings. All right. So if you apply plus, which you can call here as an arithmetic operator on strings, it is called as a concatenation operator. Right? Concatenation operator. And star operator, if you apply on strings, especially for strings, right, it is called as a repetition operator. A repetition operator. Let us see an example also for concatenation for repetition. All right. So I'm taking the same variable. All right. So one is welcome to, and the another variable is having Python. All right. Right. I'm just taking this. So what I will do, I will just perform the same arithmetic plus arithmetic star on these two strings, right? So print of every operator, whether it is a string, whether it is integer, it will return you the result. To see what it is returning, we'll use print statement. So a plus b. But if you observe here, a is a variable, b is a variable. Inside this variable, you are having some string data, not integer data. All right. So when you apply this plus operator, it will return you some result. So on strings, this plus operator works as a concatenation operator, right? So if you want to repeat the string, let's suppose B, I want to repeat specified number of times. Suppose 10 times I want to repeat this Python, right? So for that you will use this multiplication operator in arithmetic operators. If you apply on integers, it is a multiplication operator. But if you apply on strings, the same multiplication operator is called as an repetition operator, right? It will just repeat the strings by specified number of times. All right. So when you execute this, you can see it here. So welcome to Python. Both are different strings. Is it right? A is welcome to, B is Python. Both are two different strings. When you apply this plus, you are just concatenating. You are just adding one string with the other string. All right. When you use this star operator, so the star operator acts as a repetition operator. So Python is repeated specified number of times like 10, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times a string has been repeated, right? So this is how you can apply these arithmetic operators on different data types. It can be integer, it can be float, it can be complex, it can be strings, it can be list, all right? So it can be tuple, so it can be so set, it can be dictionary. So on any data type, on any value, you can apply this arithmetic operators. Next type of operators is relational operators. Next type of operators is relational operators. Is it right? So you will just derive the relation. You will just compare two things. You will just derive the relation. Right? So what are the different types of relational operators? Greater than, greater than or equal to, less than, less than or equal to. So these are different types of relational operators. But I have defined another category as equality operators. Right? So equality. So these are also relational operators. Is it right? So you are just using double equal to. If you use single equal to, you are just assigning some value inside some container. Is it right? When I use a single equal to, I'm just assigning some value. I'm just assigning some data inside some variable. right? But if I use double equal to, you are just comparing the content, right? Double equal to is for comparing the content. Single equal to is for assigning the content. Assigning is different, comparing is different. So if it is equality operators, if it is so if it is double equal to, if it is not equal to, exclamation and one equal to, it is not equal to, right? These equality operators comes under relational or comparison operators. Both are same only, but for your information, I have made it separately. All right. So you are just comparing the content. Is it right? Here also, you are comparing, and after comparing, you are just giving you the result. So the same here also, right? So always relational or comparison operators will return you that result. So what is that result? Some boolean value. Boolean value. So it is a boolean result. You are just comparing. Is it right? Madan is black, then others. If Madan is black, then it will be true. If Madan is white, so it is false. Is it right? So if you derive some comparison, if you derive some relation, it is always a boolean value, either true or false. True or false. All right. So similarly, equality also. So equality, all right. So relational operators both returns a boolean value, true or false. All right. Let us see how you can use this relational or comparison and equality operators. Both are same only. All right. So I will try to write for relational and equality operators. Relational or comparison, both are same only, right? So relational or equality operators, right? So let me define two variables. I'm using this integer data, not only integer data, you can apply this relational or equality operators on integer data, boolean data, right? Strings also, right? On any data type, you can apply this. But for your information, to make it very easy, I'm using this relational, I am applying this relational or equality operator on integers. But in the material, I have also specified other data types as well. But so if you understand this example, then that is very, very easy. Let me define a variable a equal to 10 and b equal to 20, right? So I want to just derive some relation, whether a is greater than b or b is greater than a, or whether they are equal or not equal, like this. All right. So if you see, I'm using this greater than. So a greater than b. This is what one relation. I'm just deriving between these two values. Right. Similarly, a greater than or equal to b. All right. So a less than b. A less than or equal to b. Right. So a equal to b, double equal to. All right. So a not equal to b. These are multiple relations, right, which you can just derive. Right, a greater than b. If a value is greater than b value, then it will return you some result. So it will return you a boolean result, either true or false. Similarly, a greater than or equal to b, greater than or equal to. Two things here. One is a greater, it will just derive this relation, and again it will also derive this relation. So, and between these two relations, between these two conditions, it will apply or. Right? If at least one argument value is true, then the result is true. Is it right? If you are applying logical or, we'll be discussing next. So if at least one argument value is true, then the result is true. Right? So print of a greater than or equal to b. Right? Less than b, less than or equal to b, a less than or equal to b. Right? You are just comparing the content. Right? So when you use a single equal to, it is just assigning some data, storing some data inside one location. When you use double equal to, right, what it means, there is a value, there is another value stored inside this container, whether they are equal or not, that what you are checking. So there is a lot of difference, right? A single equal to is for assigning, double equal to is for comparing the content. Let me write that point. So when you talk about double equal to, all right, so and not equal to, we are just comparing the content, so comparing the content is different, right? Assigning the content is different, right? If you use single equal to, it is like assigning the content, assigning or storing some data or content inside container. This is different, right? Assigning or storing some data inside container is different. Comparing the content is different. Is it right? So that what I am just doing it here, right? When you execute this, so it will just derive the relation and it will return you some result, right? To see what it is returning, I'm using this print statement, right? So 10 greater than b, is it true? No, false, right? It is returning you a false boolean value, right? Is 10 greater than b? No. Or 10 equal to b? No, 10 is not equal to 20, 10 is not greater than 20. So false or false, right? When you apply this logical or, it will return you a false boolean value, right? At least one argument is true, the result will be true, but both the conditions here, both the arguments are evaluating true false, so it is returning you a false boolean value. All right, so a less than b, 10 less than 20, 10 less than or equal to 20, both are true only. All right, so 10 equal to 20, is 10 the data or the value is equal to 20? No, 10, it is not equal to 20, so it is returning you a false boolean value. So 10 not equal to 20, it is returning you a true boolean value, right? This is how you can just apply this relational and equality. Relational is also called as comparison operators on any data type, right? Not only on integers. Let me take another data type as strings also, right? Or let me take boolean, right? So boolean, I'm just taking this boolean b equal to false. When you are using these boolean values true or false, always make sure first letter is a capital letter, right? If it is not a capital letter, it is not treated as a valid boolean value. All right, so I'm just applying this on this booleans, right? So true is greater than false, so internally true is represented as 1, integer value as 1, so false is represented as 0, right? So 1 greater than 0, 1 greater than or equal to 0, both are true only. Is it right? So 1 less than 0, 1 less than or equal to 0, is it a true? False, right? Is 1 equal to 0? No, it is false. Is 1 not equal to 0? Yes, it is a true. Yes, you can see it is a true. So not only on integers, you can apply on float, you can apply on complex, you can apply on boolean values, you can apply on strings also, right? Let us see for strings. All right, so if you see, I'm just storing welcome in one variable, and in another variable I'm storing python. All right, and make sure how this comparison works. All right, so to do the comparison on strings, very important. When we discuss this string data type, you will understand this very clearly, but for your information, you need to know how you can apply on strings also, these operators on strings also, that what we are learning here, right? So every character will be having some ASCII code. Is it right? During Second World War, so what a scientist have done? Scientists have done secret way of has invented some secret way of communication. That means for every character, they have given some code, right? Based on that code, they will communicate. So those codes are called as ASCII codes during Second World War time. So that has been implemented. Is it right? So every character in a string will be having some ASCII code, right? So if you want to see the ASCII code, right, you can just go for the table, ASCII table, right? So you can see these are multiple ASCII tables, right? So if you see, if it is, let me take this W and P for, so both are capital, right? So we can see it here. So this is P, which is decimal value is 80. So W whose decimal value is 87. So 87 and 80. All right. So This is the ASCII code, right? On strings, very important point. On strings, if you apply this relational or equality or comparison operators, they will derive some relation. How they can derive some relation? Based on ASCII code, right? Based on ASCII code, they will derive the relation. That too, it will not check for all the ASCII codes of the characters. Very important. Only first character comparison is done. On strings, if we apply this relational or comparison or equality operators, yes, comparison will be done. But generally, by common sense, I can say you can derive the comparison on some integer values. That means to these characters also, you need to have some integer values. Those integer values, those decimal values are called as ASCII codes. So based on ASCII codes, the comparison will be done. All right. So only first character comparison will be done. If the first characters are same, then it will check for other different characters in the same position. Right? In the first position, both are different here. But in some other strings, if both are same, like this Python, welcome. So in both the strings, first characters are same. Is it right? So first character comparison is not done. It will go and check for other characters comparison. So that comparison is done based on ASCII code. So that is the reason for the first character. What is the ASCII code? Which is W, it is 87. Is it right? So that what I am just taking from this ASCII table. You don't need to remember this ASCII table. Just try to have this for your reference. 87. For P, capital P, it is 80. I am only considering this decimal values, not hexadecimal values. Right? We don't need this hexadecimal. So decimal comparison we will do here. Right? So 87 and 80. Right? So if you apply this greater than 87 greater than 80, first character comparison, right? So 87 greater than or equal to 80. So 87 less than 80, false. It is also false. So 87 equal to 80, it is also false. Right? So so if you see 87 not equal to 80, it is also true. Right? Like this, you can also apply this relational or comparison operators on different data types. Not only integer, not only boolean, not only string, every data type. If you want to apply, you can apply this. So these are about relational or comparison or equality operators. Always these operators will return you a boolean value. You should never forget this. Even in your dream, it should come. So when anybody asks you, it should come to your mind. Right? This is what relational comparison and equality operators. You can also apply chaining. Right? So chaining is also applied. Chaining is also applied or applicable. That means if you are having multiple comparisons in one single line, you can do that chaining. Let me make you understand one simple example, right? So you can see, I want to compare 10 with 20 and it is 30 and it is a 40, right? So this is how you can do chaining. So multiple operators, you can specify one single line. So multiple conditions, you can specify one single line. So this is nothing but a chaining. So chaining of operators, it can be relational or equality. You can do it here, all right? So if at least one condition evaluates to false, then the whole result will be false. Let's suppose you can say 10 equal to 10. I'm just doing the comparison. That's it. Content comparison equal to 10. So at last I'm specifying 40. Right. So up to here it is true. 10 equal to 10, both are same. So it is also true. But if you see the last comparison, 10, it is not equal to 40. Is it right? Right. So that if at least one chain is broken, then the result is false. Right. So we can see the result print of that expression, right? So expression is different, equation is different, right? You can see it is evaluating to false. Not only equality, you can also chain this relational or comparison operators. If at least one comparison returns false, then the result is false. Otherwise, the result is true, right? This is what with respect to relational or equality operators. Like we have another type of operators which are logical operators. From the childhood onwards, we have been studying this logical and logical or logical not. When this and or not is used, if you want to apply on Boolean data types, if you want to check the conditions, right, based on some condition, if you want to perform some action, you will use this logical operators. Is it right? So you can apply these logical operators on any data type, right? It can be Boolean. Let me write it here. So it can be Boolean, it can be non-Boolean, right? So if it is Boolean, Boolean means a true or false, right? If it is non-Boolean means it can be string, it can be integer, right, etc. On any data types you can apply. So Boolean is different, non-Boolean is different, right? So Boolean means true or false. Is it right? So if it is a non-Boolean, it can be string, it can be integer, right? It can be complex. On any data types you can apply. So logical operators you can apply on Boolean data types, you can apply on non-Boolean data types. Guys, when you apply on Boolean data types, you need to understand the truth table. Is it right? So truth table is where you can have multiple arguments, right? Logical and, logical or, and not, right? So these are logical operators, right? So with the help of this truth table you can understand. But before this, let me make you understand three simple statements, right? When you are applying on Boolean data types, when you apply and, right? So when you apply and, if both arguments are true, then only the result is true. Is it right? So if you are applying logical and, both arguments must be true, then the result is true, right? So the result is true, right? So if you apply on logical or, if at least one argument is true, is it right? If at least one argument is true, right? If at least one argument is true, then the result is true. Otherwise the result is false. At least one argument. Coming to this not, right? So what this not will do, this not is nothing but a complement, all right? So if you are having true, it will return you a false, right? Or if you are having false as an argument, right, it will return you true, right? These are the different types of uh, logical operators on Boolean data types, either true or false, right? So if you understand this truth table, then it is very easy. If you want to apply logical and, both arguments, either A or B, both the arguments must be true, then only the result is true. Otherwise the result is false. If you see in all the cases, if you are having at least one argument true also, if you apply this logical and, the result is false, right? But if you see logical or, at least one argument is true, the result is true. First three conditions. But if you see the last condition, the result is false. But why? Both arguments are false. Coming to this complement. Complement means negation. If you are having true, you are having false. If you are having false, it will return you true. So this is what a truth table, right? So you can apply this logical operators on Boolean. First, let us see on Boolean, right? Now we'll go for non-Boolean data types, right? Boolean operators. So let me take two variables whose is having some values A and B, false and true. I am taking one scenario. Like this, you can also apply on other scenario, right? Every operator, right? So it is logical operators, right? So every operator will return you some result. So I am using this print statement. So A and B, logical and, right? So A or B, right? So similarly, print of not B. I am using this complement also, right? So A and B, if you want to apply logical and, both arguments must be true. If at least one argument is false, the result is a false. Is it right? This is what by concept I am going. But if at least one argument is true, logical OR will return you a true Boolean value, right? So not means complement, right? So not be means it is a true. Not false means it must be true, right? If it is not false, if this is not Madan, there can be other person, is it right? The same, you can understand, right? You can see it is false, it is a true, it is a true, right? This is how you can apply on Boolean values. You can also apply on non-Boolean values, right? So non-Boolean means here multiple things comes into picture. So non-Boolean means, so it can be integer or it can be string also, right? For your information, I'm just taking integer and string. So 0 means false, right? So 0 means false, 1 means true, true Boolean value, and empty string, very important, empty string, right? So empty string is also evaluated to false, right? Empty string is also evaluated to false, right? Just try to understand this much, that is more than enough. There are a lot of points I have also specified in the material, so you can also observe that. All right, so let us see on a simple example. All right, so let me take two more variables, c equal to python. All right, I am taking another empty string, so d equal to an empty string, right? On this two variables I want to apply this operators, right? So print of c and d, right? So print of c or d, right? So print of not d, right? This is what I'm just using. So if you see here, try to observe the result, we'll see uh, the result, right? So empty string, it is false, right? Empty string is false. All right, so false means empty string. Try to observe this. So if you are having some characters in the string, so it is a true Boolean value. So empty string means a false Boolean value. Non-empty string is what? A true Boolean value. All right, so if you see c and d, one is a false and one is a true. If you want to apply logical and both the arguments must be true, if at least one argument is false, then the result is false. False means empty string, is it right? That empty string has been printed. If you see here, logical or, logical or, so if at least one argument is true, then the result is true, right? So the result is true means what is true here? Non-empty string. So that non-empty string, you can see it here. All right, so not false, d, which is an empty string, which is false. Not false means it is true, is it right? The true has been printed in the console, right? This is how you can apply these logical operators. Just understand this much only, it is very very easy, right? If you understand this much, then it is more than enough, right? 0 means false, right? 1 means true, em empty string means false, right? Let me write a non-empty string, non-empty string. Let me take python, right? So which is a non-empty string, so it will evaluates to true Boolean value. Very very important, right? Logical operators and or not is applied on Boolean data types and non-Boolean data types. All right. So now let us see assignment operators. At assignment, they will assign the value. That's it. They will assign the value. Let's suppose up to now we are seeing, right? You can see true is what a value you are assigning to this variable. Is it right? So this equal to is what an assignment operator, right? False you are assigning to this container, right? Python is assigning to this C variable. So non-empty string is assigning to this C. So empty string is assigning to this D, right? So assignment operators are used to assign value, right? Assign value to variable, right? So assign value to variable, right? You can combine this assignment operator with some other operator. So assignment operator plus other operator. So what those other operators, right? You can combine with arithmetic operators. So if you combine assignment operator, nothing but equal to, is it right? Assignment is nothing but assigning a value. How you can assign a value? By using equal to, right? So assignment operator plus other operators. If you combine, it will return you a compound assignment operator. Compound assignment operator, right? If you see this, you will understand this very clearly. Equal to, not a double equal to, single equal to, is combined with other operator, plus operator, right? So arithmetic addition, right? Addition assignment. Minus equal to subtraction assignment, right? The same you can just define. So I plus equal to 8, right? You can see this is what an operator, right? So this is what the short notation. You are just combining equal to with other operator, so it is returning you a short notation. But if you see this generally, it is internally represented as I equal to I plus 8. If you want to project that you are like an expert, if you are having some experience, right, just go for this notation. So internally it will be treated as like this, right? So I minus equal to 8, subtraction assignment, so I equal to I minus 8. At multiplication assignment, I star equal to 8. So I equal to I into 8. Is it right? I'm just using two operators. I'm just combining two operators, assigning and at a time doing the operation. So which is a compound assignment operator. Right? So internally these are represented like this. So I double star, which is nothing but an exponential operation. So I equal to I double star 8, so which is square, or which is eighth power, right? So modulo division, floor division, right? Normal division. So these are assignment operators, right? Let us see one simple example, right? So for everything we need to see an example. We need to see, we need to learn the concept. We need to apply that concept, right? Assignment operator. Right? I'm just using one simple uh, assignment operator. Let me take x whose value is 10, right? I want to multiply this x with 2, right? 10 with 2. So to multiply, what I can do, x, I can use a star operator, which is a multiplication operator, right? So x into 2. So what it will return you? It will return you some result. Is it right? So after returning, I want to update the value inside the same variable. All right. So I'm just using this, right? X equal to x into 2. All right. So I will just print the x, right? Right now I'm just updating after performing some value, right? When you see, right? So x previously it is a 10. I'm performing some operation, so it is a 20. At the same operation in one single line, how you can specify, right? So x star equal to 2, right? That means the same internal is represented as like this, x equal to x into 2, right? So x equal to x into 2. So when you see the result, right, so you can see the same result you have got. So if you want to project that you are like an experienced, you can just use this notation. You can also use this if you are having some confusion with this. You can also use this, but when you use equal to, you are just assigning some value to some container, to some variable. If you combine this assignment operator with some other operator, which is a compound assignment operator, that mostly will use arithmetic operators only. And this is what with respect to assignment operators. Now let us see the ternary operators. Right. So generally, I want to print my name. Right. So how I can do, print of this is KMR. Right. So my short name is KMR. Right. This is how I can use. Is it right? But I want to print this based on certain condition. Based on certain condition, I want to perform this. Right. For this, I will use conditional statements. Right. So if specify the condition, right? So if the condition is true, if the condition is evaluated to true, the body inside this if will be executed. In the next class, we'll discuss this control flow. You'll understand this very clearly, right? How you are writing this in multiple lines. But if you want to represent this in one single line, you can go for ternary operator. Generally, the same if else conditional statement in one single line, you can specify, that's it. That is nothing but a ternary operator. So you can also specify some other action as well, right? Else, if that condition is not true, you can just print this, right? So print of hello guest, right? So hello guest, some simple message I can print, right? Let me take this, let me execute this first. Post that, we'll see how this ternary will work. ternary operator. Right, so I'm just using this, guys. So condition is, let me take a true. Condition always evaluates to true or a false boolean value. Is it right? So I'm just using this. All right. So let me execute this first. All right. So you can say this is KMR. Why? Condition is true. This action one is executed. If the condition is not true, so action two inside this else block will be executed. Is it right? So I'm specifying false here. Right. So when I specify false, action two inside else block will be executed. Action one, action two. Right. Based on certain condition, you are executing this. If you see how many lines I am writing, total 4 lines. But I want to achieve this in one single line. To achieve this, you will go for ternary operators. First, you need to understand the syntax, right? So what is the syntax for ternary operator? Syntax. Try to observe the syntax. It is very, very easy. First, we will specify the condition. Is it right? If condition, right? If condition, else. You will also specify else. Good. Right? You will also specify else. Right? So if the condition is true, right? If the condition is true, it needs to execute this. Is it right? Just try to specify that. Right? If the condition is not true, right? Else you need to execute some default action, which is action 2. You can think of like, you can also specify multiple actions, right? When we discuss this conditional or control flow in Python, you will understand this very clearly. But for now, this much only you need to understand. All right. So if the condition is true, return this first value. It can be written also, right? If it is not, just return or print this second value. All right. So instead of this, let me specify some value, first value. So it is very, very easy. It is a second value. Generalizing this. All right. So second value. So if the condition is true, return first value. If the condition is not a true, right, return second value. So that's what it means, right? So in the similar way, right, what I will do, I will try to check which is greater or which is a minimum value. All right. So let me take A, whose value is a 10, right? B, whose value is a 20, right? So I want to check which is a minimum value, right? So to check if A less than B, I'm just specifying some condition. All right. So just so you can just print. So in this case, what I will do, I'll just go for by this syntax instead of writing in this syntax, right? So if A less than B, return A, right? So what is that first value? A is what the first value, right? Else return the second value. So what is that second value? B is what the second value. So that what you are just doing it here. You can directly print that, or you can store it in some variable and you can use that in subsequent operations, right? So when you execute this, right, you can see A less than B, 10 less than 20. This condition is true. So it is returning you the first value. Let's suppose if I specify 40, and when I execute this, right, you can see 40 less than 20. Is it a true? No, it is a false. If it is false, else block will be executed. So if else, then second value. What is that second value? B. I'm returning here, right? So you can see the same result has been printed in the console. And this is how you can use ternary operators. Like this, we also have identity operators and membership operators, right? What this identity will do, guys, it is very easy. Identity operators, there are two types of identity operators. One is and is not. These are two different identity operators, right? What they will be used for? They will be used for address comparison. Address comparison. Simple, that's it. Address, for comparing the address, you will go for identity operators. By the simple statement, you will not understand anything. Let me make you understand with a real-time example, right? Right. I'm just taking two shapes, right? One is this circle, right? You can just understand. So there is a variable, right? Let me define a variable. X is what? A variable, right? So X is what? A variable, right? This variable is storing some data. It is storing some data. right? What that value is, that value is a 10. That means x equal to 10, right? In Python, everything is treated as an object. Is it right? In Python, everything is treated as an object. Every object will be having some address. Is it right? So it can be having some address, right? So 10 is what an object, x is what a variable pointing to this object, right? So another thing, it is having some address. Every object will be having some address. There is another variable, right? So there is another variable y. There is another variable y, which is also storing some data. That data is, right? So the same data. So x equal to 10, y equal to 10, right? X equal to 10 and y equal to 10. That means 10 is having some address. 10 in the Python memory, which is an object, it is having some address, right? And 10 it is having some address. If you observe here, x is pointing to same address, y is pointing to same address. If any variable is having some content, if the content is same, then if you are just deriving some relation based on some address, right, you can go for identity operators, right? So let me make you understand. By this, you will be able to understand that, right? So identity, right? So if you see x equal to 10, I'm specifying y equal to 10. First, let us see the address, which address it is. So print of id. To get the address, I will use id, right? Print of id of x, right? So id of y. Is it right? So if you see the addresses, so both are same addresses only. That means x is 10, y is also 10. 10 means an object. Both the variables are pointing to same object. So that object is having some address, same address. Is it right? You can see the same address. You can understand the simple diagram. But if I specify x equal to 10 and y equal to 20, they are two different objects, two different addresses, right? You can see this is one address and this is one address, right? Anyway, you will get the address. If you want to do the comparison on addresses, address level comparison, if you want to do, you will go for identity operators. For before using that, let me make you one simple thing also, right? In this case, what I will do, right? So this x is pointing to, right? So another object, right? So whose value is a 20 in this case, right? So in this case, if you see, it is having two different addresses. It is right, address 1 and so this is address 1 and this is address 2, right? So x equal to 10, y equal to 20. Both are objects, two different addresses, right? So the same example you can see it, two different addresses, right? If x equal to 10, y equal to 10, both are having same address, pointing to same objects. If you are having two different values, both are pointing to two different addresses. If you want to do address level comparison, right, you can go for these identity operators. All right. So print of, right. So x is y. That means x address is equal to y address, is the same as y address. That was it means, right? Similarly, you can also use is not. All right. So x address is not same as y address, right? This will be a true boolean value in this case. So this address comparison which you are performing by using these identity operators will also return you a boolean value, right? If both the addresses are same, then it will return you a true boolean value. Both the addresses are not same, so is will return you a false boolean value. The exact opposite behavior of is not. If both the addresses are same, is not will return you a false boolean value, right? If both the addresses are not same, if they are different, so is not will return you a true boolean value, right? So if you see in this case, is will return you false, right? Both are pointing to two different objects, two different addresses. If it is not, both are different, so it is returning you a true boolean value, right? So this is what identity. Coming to this membership operators, all right? coming to this membership operators. Membership. So these membership operators are two different types, like is not and is. Right? For membership also you have two different operators. One is in and not in. Right? So in and not in. Right? These are two different membership operators. Why? What is the use of these membership operators? Why we want to use them? For checking the presence. Checking the presence. Right? For checking the presence of an item or object. Right? Item, object. Right? You can also call element sometimes. Right? So element. So checking the presence of an item or object or element in a sequence. In a sequence. Or sequences. It can be list, right? It can be tuple, right? It can be dictionary. It can be range data type, right? So it can be a set. So like this, we have multiple sequences. Is it right? So sequence consists of multiple elements. In that sequence, if you want to check a specific item, a specific object is available or not, you will go for this membership operators. Identity is for address comparison. Membership is for presence checking, right? Checking the presence. All right. Let us take one simple example. When we discuss list tuple, we'll apply on those respective data types. All right. So let me take this string. So string is also sequence, guys. Sequence is nothing but a collection, right? So that's what I'm just taking it here. Let me take the sequence. Membership operators. Right. So let me take a whose value is Python. This is a collection of characters, right? Which is a string. So which is a sequence. Right. In this sequence, you are having multiple elements. Is it right? Each character is an element, is an object, is an item. Right. To check an specific item is available or not, you will go for membership operators. Right. So every operator will return you some data, some result. Right. I'm using this print to see what it is written. Right. So I need to check yes in A. Right. Similarly, yes, not in A. So two different membership operators, in and not in. All right. So this is an item. This is the sequence. Whether this item is available in the sequence or not, to check the presence, I will use this membership operators, in and not in. Yes is present in this sequence. No. If an item is available in the sequence, in will return you a true Boolean value. If the item is not available, it will return you false Boolean value. Exact opposite behavior is not in. If the item is available, not in will return you a false Boolean value. If the item is not available, not in will return you a true Boolean value. Right? The exact opposite behaviors we have. Right? Yes is not in this sequence, so it is returning you false. Right? Is yes is available? No, it is not available. Right? Whether this yes is not available, it is not available, right? So it is returning you a true Boolean value, right? This is what with respect to membership operators. You can also apply for list, tuple, dictionary, all right, for other data types too, right? At last, we'll discuss this Boolean operators, right? So if you see, we have bitwise and bitwise operators. Sorry, so bitwise and bitwise or bitwise XOR, bitwise ones complement, left shift, and right shift operators. So in automation, generally will not use this that much, but if you are going for development, so these operators are very, very important. All right. So we'll see one example. Post that we'll see how you can use this in real time. All right. So bitwise operators. This name itself says if you want to apply these operators, you want to apply bit by bit. Right? So how you can convert a decimal to a binary number system? So that what I have specified in the material, just go through those steps. Those are all not required. I hope you already know this. From the childhood onwards, we know how you can convert any number system to another number system. Right? If you don't, you can see, you can just follow in the material. The same I have specified. Right? Let us see one simple example for bitwise. Right? So bitwise operators, right? Let me take two variables, a whose value is 10, b whose value is 2. right? So what is the binary representation of 10? Right, it is 1010. Is it right? If you divide 10 with 2, you'll get these digits, right? If I divide, right, so 2 with 2, because I want to convert to target number system, so you need to divide that with a target number system. So to binary number system I want to convert, I'm dividing this decimal with 2, right? So you will get 0 1 0 0, right? 0 1 0 0, right? These are binary number system. So bits, right? Zeros and ones. On these bits, if you want to apply some operation, right? Some operators, you can go for bitwise operators, right? So I have the code already, right? If you see, so bitwise and, right? So both bits must be 1. Otherwise, it will return you 0 as a result. If it is or, right? So at least one argument bit is 1, it will return you 1 as a result. Like this X are two different bits, right? Bitwise not left shift and right shift operators. So left shift will try to shift specified number of bits in the right side and adds the same number of bits in the right side, right? So left shift will shift specified number of bits left side and it will add to the right side that many number of bits. Coming to this right shift operator also shifts the bits, right, to right side, but adds that many number of shifted bits, they are zeros to the right side, right? This is what on a high level you can just understand this bitwise operators. Don't spend much importance on bitwise if you are going for automation, right? So let us try to execute this run bitwise operators. You can see these are respective results. So 0 and 0, it is a 0, is it right? So this is what the result, right? Again you are converting this binary to decimal, all right? So if you convert that binary to decimal, these are what respective values, right? After shifting, right shifting and left shifting also, after applying this complement. And one more important thing, if it is a positive value in Python memory, it is directly represented. If it is a negative value, so it is represented in the 2's complement form, right? 1's complement, 2's complement. When we study this digital logic design, so we'll be able to understand this, right? At the graduation level in the second year, we used to learn this, is it right? The same you can apply for any programming language, not only for Java, not only for Python, for any programming language you have their respective bitwise operators. But if you see what are the applications, right? So if you want to control low level devices like LEDs on and offs, with flags you will just control, is it right? 1 or 0, right? So 1 means high state, off means low state, right? Flaction permissions, data compression, right? If you want to pack multiple small values into a single larger value to save space, you can go for data compression techniques using these bitwise operators. For networking, for graphics and game development, for error detection and correction, you'll use this bitwise operators. And at last, you are using these multiple operators. Good. What is the operator's precedence? Which operators needs to be first? All right. So operators of precedence, very important. Operators precedence. Operators precedence. Just to follow this simple rule, PEDMAS, PEDMAS or PEMDAS. PEMDAS. Both are same. Why? If you observe DMMD, right? So both are having same priority. D means division, M means multiplication, right? So P means parenthesis, E means exponentiation, so D means division, M means multiplication, right? A means addition, S means subtraction. In the other case also, MD, both are reversed. Why? Division and multiplication both are having same priority, right? Based on that expression, either division or multiplication will be evaluated first, right? So PEDMAS is what an operator's precedence, right? If you see, first is parenthesis. Whatever the result which is there inside a parenthesis, that needs to be evaluated. Next, exponents. Next, you'll need to go for multiplication and division. So both can be interchangeable. Both are having same priority. And at last, addition and subtraction. This is what an order. right? Operator precedence. Let's see one simple example. So how you can apply, how these expressions will be resolved, right? So PEDMAS or operators precedence, right? So operators precedence, right? So I'm just taking one simple expression, 3 plus 6 into, right? So 5, right? Exponent of 2, so 5 square it is, right? So divided by 10 minus 4, right? So I will store some data in some variable. Result is what a variable. I'll just print some result, a print of result, right? So when I execute this, you can see it here. So 14.0 it is getting, right? Based on this operator's precedence, it is executed each and everything inside this expression, all right? So first parenthesis expression is evaluated. 5 square is a 25, is it right? 5 square is 25, right? So next, it is performing this multiplication. So 6 into 25, so it is 150. 150 divided by 4, right? It is returning you a floor division operation, right? It is performing this division operator, not double forward slash, a single forward slash, is it right? So a division operator, it will return you a float value. That whole result is a float value, is it right? If you are performing division, the result is a float value. By this I can say the whole result is a float value. The same you can see it here. So based on this operator's precedence, respective expressions will be evaluated. This is what operators in Python in a detailed way: arithmetic, relational, equality, and lot of operators.